I'm off and running with my next timing. So, we're also going to talk a little bit about certification levels. Levels 1, 2, and 3. And we're going to talk about application certification at the very end of this speech. So, the first topic is ultrasonic thickness measurement. A little bit of the theory, a bit of discussion, again, selfish learner, and equipment demonstration during 10-minute breaks. I think we're going to try this. We'll talk for maybe about 30 minutes or so. Like I said, I'm having about 40 minutes set aside for each one of these topics. You might not learn everything, but it might give you a little bit of knowledge and a little bit of curiosity to do some more stuff on your own. So the first product, as I talked about, is called the Cygnus. It's from Cygnus. And again, when you download that PDF, it's going to take you directly to this website, so you don't need to copy it down. But what we're talking about is a product called the data logger. Now, how many people here are doing thickness measurements? Quite a bit, okay? What is the hardest part? Laying out the route ahead of time and recording the information, either writing it down or storing it somewhere. Then interpreting the information afterwards, where you can, come up with an average value of thickness and write that report. I like this particular model of unit. It's the data logger, which allows you to go ahead and set up individual measurements, set up multiple measurements, and set up grids. So all these things you can lay out ahead of time or lay out when you're actually in the field and store the information. My partner in crime over here, Mr. Moody, we were doing some stuff together, and you were using an audio gauge that we had to go ahead and write things down by hand. And then we also are using the data logger, and we found that we could actually do our work a lot faster by being able to just go ahead and take the reading, punch a button, and it would automatically log it in with the time of day and all the rest of the stuff that you need for your reports. So again, we'll demonstrate that during the 10-minute break, and you can kind of see what's going on in terms of how it works. This is the website that talks about Cygnus. It's going to be annoying.
Put it on vibrate.
There you go. Then I'll just smile. So the theory. The transducer or probe is placed on the smooth surface of material to be measured. Use a couplant or gel applied between the transducer and the material to be measured. And again, what I'm going to be showing you is a thickness rating or no thickness rating. There are lots of things to be done with ultrasonics. You can do defect analysis, you can look for voids and disbonding. This is not the equipment for that. The other equipment just generates a sine wave, and you learn how to read the sine wave to see whether there are voids in materials. You can be measuring things like gel coat thickness, you can look at fiberglass, anything that does not have air in it, because what happens with the ultrasound is that when a wave goes through, it's going to hit the back wall and come back to the transducer. If there's air in there, you're not going to be able to see it. So what I'm telling you is that if you're looking at a boat that's cored, it's not going to tell you the thickness to the back wall of that. It's going to tell you the thickness to where the core begins. So there's a short burst of high frequency sound wave that gets sent through that couplant gel. Some people use expensive gels. I actually use something from the dollar store. It's called LA Looks. It's just regular hair gel. When I talked to the manufacturer, he said, Jack, you can use anything. If you really come into a crunch where you don't have an acoustic coupler, you can actually use something like water. But what you need to do is make sure that there's no air gap between the transducer and the surface that you're looking at. So that sound wave reflects off the back wall of the material and back to the transducer. And the time it takes for that sound wave to travel back to the transducer is what's translated into thickness. Different materials have different sound velocities. So for example, If your calibration standard is mild steel, you could go ahead and convert it, if you're looking at aluminum, by multiplying that result by 1.068. Now there are tables that you get with the equipment that tell you what the conversion factors are. If you're only going to be working with aluminum, maybe you need to buy a specific probe for doing the aluminum. So we're going to talk about something called single echo versus multiple echo technology. And hopefully this will be loud enough. And this is something that the Cygnus product does that I use. It actually shoots through coatings. Now the coatings have to be adhered to the metal so that there's no air gap there. But the nice thing about using this technology is that when you're doing metal thickness, you don't have to grind away the paint, you don't have to have a shiny metal surface to work with, you don't walk away with somebody who has to clean up your mess. Or you don't have to go ahead and pay additional money to try and return that coating back to its original condition. I had a question back here. Yes, sir?
Does it have to be a smooth surface as far as no bumps or?
It's better. The question was, does it have to be a smooth surface versus no bumps? The answer to that is, it's better if there's no bumps. If there are bumps, maybe you have to go ahead and move the transducer around until you do get a place where there is no bump. So give it your best shot, but we'll talk a little bit in a few minutes about the different types of problems that occur when you're doing UTM. So again, this little graphic here shows how this product works. It says that measuring between points T2 and T3 is actually how it's doing the measurement and giving you the measurement. Something very interesting about this product is you're either going to get a reading or you're not going to get a reading. Some other UT methods, you get a reading, but you don't know whether it's accurate or not. So in this case, what we're saying is that if you don't get a reading, you're not tempted to write down something that might not be correct. Does that make sense what I'm saying? All right, so that's the single versus the multiple echo. We're getting that digital readout and thickness reading, or no reading at all. Two different ways to apply this. You know, one of the things is, what is the allowable wastage there? You're looking at maybe a ship for ABS. I'm not ABS certified, but I use their measurements and their guidance when I'm reporting back to what the metal plate thickness is. The difference between what it was originally laid up as and what we have right now. The other thing that I'm looking at is kind of like when you're using your moisture meter. You're looking at relative changes across stuff. So that might be another way that you're using it, where you're saying, okay, well, I have a reading of 1/4 of an inch here, and over here I have a reading of 1/8 of an inch. Yeah, there's something definitely going on. Now, Bob and I were doing a project on lift boats, and I need to go ahead and get rid of this because it's going to drive me nuts to hear that clicking, almost as bad as my phone. But Bob and I were looking at lift boats out in Texas, and we're sitting there and we're gauging it, and man, we had a huge disparity in between things. And we're looking at each other, is it the gauge, is it the gauge? Well, no, let's go ahead and record what we have. And when we were doing some discussions with the people who were maintaining the boat, I said, oh yeah, we replated over there, and we thought that we should replate thicker than what the original specification is because we wanted to have it better. So again, there's a little bit of common sense, as I said before, you know, it's sort of like find out why. And in this case, it had been replated. So here's a reference to ABS, and here's a reference to allowable wastage on conventional vessels under 295 feet. So take a look at this when you download it. If you don't already have references to what ABS says, you know, you have another source to look at. keep in mind that other people will use different classification societies, and they're going to have different acceptable wastage. So an example would be, they'll say, well, if the main deck plating up here, if the wastage is greater than 25% when it was originally laid up, you need to think about replacing it. So whether you're looking at a small little boat in the St. Johns River where they have a little working platform, or you're looking at a landing craft that's going to be doing some business over in the Bahamas, or lift boats that Bob and I did recently over in Texas, the whole thing in terms of mild steel is that objects are going to be corroding in most cases from the inside out. So here's a little example of this back hatch on that little working platform that's out there in the St. Johns River. A little dredging company would use this small little dock with a with a lift on it to go ahead and put in posts and stuff like that. On the left-hand side, you can see my gel and the hammer and scale that came off. I'm going to open this up, and you can see, well, it kind of makes sense. The hatch is pretty close to the water in the back, and hatch doesn't really seal tight at all. And so what happened is a flat plate beneath it, when you opened up the hatch, had a bunch of scale on it. This isn't a huge job by any means, but this is somewhere where somebody needed to know, man, I see all this scale. Do I need to consider replating? How bad is it, Jack? Well, here's a picture of scale and the thickness and the porosity. Okay, so as I said before, this concept of using audio gauging for thickness isn't going to go ahead and read through scale like this. You have to knock the scale away. The other thing to keep in mind is, here's another job that I was doing where the purpose of measurement was a little bit twofold. We're looking at tank wall thickness and the characterization of the interior surface. Again, this is that concept of reading or no reading. So here's a Grand Banks 46 fuel tank. Somebody's getting ready to buy it. The fuel tank had inspection ports on it, but it's a pre-purchase survey, and the guy's trying to figure out, is this something that I need to follow up on? Well, you can look at the Raycor filter on this, and if you look really hard, you can see a little bit of iron filings in here. But the interesting part about this is that when I did the audio gauge thickness, there really wasn't much change in the plating. But guess what? In these areas down here in the bottom, it was difficult to go ahead and get a reading. So what was that telling me? It's saying, yeah, I see a little bit of stuff here in the filter. I'm having problems getting readings in certain areas of the tank, and it's not because it's baffled. There's probably some corrosion going on the other side of that surface that's not letting that signal come back to me. Again, Bob and I were doing some work in the front surface on those lift boats. There were some plates that really looked good, but we put the audio gauge probe on it and we just couldn't get readings, and this was stiffeners inside. And we looked on the other side, my God, there's a lot of scale there that had been freshly painted so you couldn't see it. When you chipped off that stuff, all of a sudden, my God, you got a reading. So common sense gives you a little bit more idea of what's going on. So that's how I'm using audio gauging. Some general points on the ultrasonic thickness measurement. Well, guess what? Rough surfaces and badly corroded both sides, you may need to move that transducer around. We talked about that just a few minutes ago. The other thing is, hey, you need to use plenty of couplant for good contact, and you want to avoid measuring over an external pitted surface. So if you see a pit in the piece of metal that you're looking at, be it aluminum or steel, you don't want to measure over top of that pit because it's going to give you a false reading. You want to move it a little bit to the other side. The thing about doing audio gauging is the fact that what happens with that is you're usually only looking at a square inch, depending on how big the probe is. So I mean, you're trying to characterize a huge piece of plate, something like that, by taking a 1-inch measurement. You're going to have to take a lot of measurements or follow a certain standard that says, look, take 5 in this particular area. Multiple echo. Even though it's great for going through paint and other surfaces, It's not going to work on a piece of material that doesn't have a parallel surface on both sides, because it's not going to come back. And of course, plate and pour quality with the heavy scale that I just showed you, where I had my little tape measure next to it, and you could see all the inclusions in the scale. That ultrasonic wave will be scattered to the extent that the measurement may not come back. You have to chip it off in order to look at the metal down below. What I'm going to do now is quickly flip over to, or hopefully quickly flip over to my website. We specialize in non-destructive testing, and I had said in the beginning when we were talking about different non-destructive techniques, I was selecting things that complement each other. I'm going to play a little video for you, and hopefully nobody here has a problem with flashing lights and music and stuff like that, but here we go.